Hello everyone! Today myself, MESHALINE and my friend Latchana going to present Homopolar Motor experiment. Homopolar motor is a direct current or a DC electric motor which produces constant circular motion. And the objective of this experiment is to make all homopolar motor to verify Lorentz force. The apparatus needed for these experiments are magnets, AA batteries which is 1.5 volt, copper wire which is not insulated and a wire cutter. So let's see the procedures to proceed the experiment. First step is attach the magnet to the negative side of the battery. Second, bend the wire so that one end touches the positive battery terminal and the other touches the magnet under the negative battery terminal. So what happens when the wire is placed on the battery? As the copper wire grazes the magnet, the wire begins to spin. Here is the concept behind this experiment. The copper wire connects the positive battery terminal to the magnet at the negative battery terminal, completing the circuit. Consequently, a current of electrons will flow through the wire. Due to the close proximity of the magnet at the bottom of the battery, this current actually flows in the presence of a magnetic field. When current flows in a magnetic field, it will experience a force called the Lorentz force. Lorentz force is the force on a charged particle due to electric and magnetic fields. A magnetic field will be produced perpendicular to the current, as both the current and the magnetic field act in opposite direction. The Lorentz force produced will cause the wire to spin in a circle. Lorentz force causes the wire to rotate in a clockwise motion. Because the polarities of the magnetic fields do not change, the direction of the force will not change, and the wire will rotate in a constant circular motion. This kind of motor is called as homopolar motor. When a current carrying conductor is placed in a magnetic field B, the magnetic force lag on that conductor. Magnitude of the magnetic force acts on the current carrying conductor is given by Fb equals to BIL sin theta, where Fb represents magnetic force, I represents current, L represents length of conductor, B represents magnetic field strength, while theta represents angle between length of conductor and magnetic field strength. Here are some precautions we need to follow during this experiment. Firstly, the wire can be bent to form any shape, but one end must be touching the positive terminal of the battery and the other must be in contact with the magnet. Secondly, the key is to make a shape with the wire that allows it to balance properly. If it is unbalanced, it will soon fall off the battery as it begins to spin. Thirdly, please be careful if making your own DIY homopolar motor, as the wire and battery can become very hot. That's all from us. Thank you for watching.